in our textbook, we're on standard deviation calculations, and I thought we would do our project based on your test scores from last semester. In our book, we're on page 656 and so on. Last semester, you had the final test and then 4 other tests. I did a calculation of the average for each one of them, and here's how I did it. I typed equals average, and then parentheses, and I just highlighted the cells that there were for that test. Then I did the standard deviation of the population, STDEVP of the population, and I did that calculation. Now I did that for the final test and for each of the other 2 tests. The margin of error, if you remember, is 1 over the square root of however many students there were, and in this case there were 20. So that was the same amount. So in other words, we could be off by 22%. That's quite a large margin of error. And that's why we usually don't do standard deviation on such a small sample. But let's do it just for practice anyway. The first test that I'd like to show you is the grade distribution for the final test. If you notice, the average was 85, which was a pretty high average compared to the other tests. And if you notice, there were, 10 or 11 students that had A's, 4 of them that had B's, 3 of them that had C's, and then it looks like 2 of them had D's. Then you go to test 1. Test 1 had an average score of 84. Standard deviation was a little bit higher, so the test scores for test 1 were a little bit more spread out. And if you notice, that's true. 8, 6, 4, and then 2, a 1 and a 1. So there were fewer people that had A's, and the test scores were more spread out. Test 2, notice there were a lot of people with A's, and the test scores weren't very spread out. Now there was, 1 student or 2 students that had, 1 student had a D, and another student had a C. And if you notice here on our averages, the average was very high, but the standard deviation was very big. In other words, the average was high, but the student scores were very spread out. So, in fact, test 2 was the most spread out scores there were. Test 3, it looks a lot like this one that we had for test 1. Notice the scores are pretty spread out, about the same as they were when we had test 1. And as you can see, the test 3 average and the test 3 standard deviation are pretty close to the test 1 scores and standard deviation. Test 4, notice, test 4 we had almost nobody got an A. Only 2 people got an A. Most of the people got B's, and a few people got C's and D's. And as you can see, test 4 was our lowest average and our smallest standard deviation. So everybody didn't do very well on test 4. Well, in our discussion that we had in class on Wednesday, we talked about how to compare those scores. So here's a made-up student. We'll call him Kevin. And these are the scores that he had on his tests. Let's see if we can come up with a z-score for each one of these. Remember, the z-score is the fraction of your score, which in my case is 75, minus the average, 87.5, over the standard deviation, 11.8. Now, according to the calculator, my average is negative 1.06. Negative 1.06. Let's look at the next one, test 1. Fraction again. My score is 75 again, but the average this time is 84.6. And the standard deviation is 12.89. 9. Now when I calculate it, I get negative 7 or negative 0.75, I think that was. No, 74. So what does that mean? Well, if you compare these two tests, my score of 75 was a long ways below average on the final test, but it wasn't quite as far below average on test 1. The negative means that I'm below average. Okay, let's look at test 2. Same calculations. This time my score, oops, I gotta get the fraction thing going. My score was 90 minus 92.25 over the standard deviation of 13.85. This time, my standard score is negative 0.16. So I was below average again on this test. All right, let's go to the next one. Test 3. Now my score is 90 again, minus 86.55 over 11.52. Now my z-score, oops, I forgot what the number was already. My z-score is 0.30. It's a positive number. And the reason for that is I'm above average. I got a 90, the average was 86. Let's look at the last test. So we have fraction 90 minus 80 over 7.49. Now, my z-score is 1.34. So oops, I'm sorry. That was 1.34. I'm way above average this time. So what we really need to do is to be able to translate these scores into a more fair, and that's why we call it a curved score. So you have to go to the tab called Grade Matchup, and we're going to look for the z-score of negative 1.06. Negative 1.06. So it's right around a 69 or a 70. Oops. So I'm going to say 70. I'll always give myself the benefit of the doubt. Next one, negative 0.74. Negative 0.74 is a matchup score of 72.7. Why do I keep doing that? 72.7. All right, next column. A negative 0.16. Oops, what am I doing here? Negative 0.16. So about 74.7. 74.7. All right. Next one, I had a positive 0.3. Positive 0.3. Right around 75.8. And in the last case, I had a 90, which is 1.34 above. Oops. 1.34 is a 90. Now, in my case, when you would give a grade then, you always would go by the higher of those two scores. So in the first case, in the final test, my example score was higher than if I would have used the curve, so we'll go with that one. The same is true with the second case. The same is also true with the third case, the fourth case, and the last case. In fact, my score always benefits by using the examples. Well, okay, so what I want you to do then is to use that email that you got. I sent you your scores, and you do your curved score and see what the grade would be, your z-score, and then your curved score for each of those 5 tests that you took first semester.